First of all, what is electrochemistry? Electro means electrical charge, chemistry, chemical charge. So, in this topic, we will deal either the conversion from electrical energy to the chemical energy or from chemical energy to electrical energy. Two such sort of changes are possible. Conversion of electrical energy to chemical energy. Or else from chemical energy to electrical energy. The conversion from electrical energy to chemical energy can be studied by using electrolytic cell. Then the change from chemical energy to electrical energy can be studied by using galvanic cell. So first of all, let's see what is electrolytic cell. First point is this one, the change from electrical energy to chemical energy, and that too electrical energy to chemical energy. And this occurs, it's a non-spontaneous reaction. What do we mean by non-spontaneous? By its own, the reaction won't happen. We need to conduct the reaction to happen by providing some input energy, or else we can say simply by placing a battery. By connecting a battery, the whole reaction can occur. And that should be a non-spontaneous. By its own, it will not happen. And one more thing, Gibbs free energy is always be positive in this case. What is Gibbs free energy? Useful energy, or else energy which is maintained by the system, is always positive in the electrolytic cell. So let's see the construction of electrolytic cell. So this technical constructed by using a container. And one more thing, the electrodes here used are of platinum electrodes. We use platinum. Why? Because platinum is an inert metal. It will not involve in the further reaction. If at all this electrode is also going to perform in the reaction or involve in the reaction, then the products from on the anode or cathode will differ. For that, to avoid the reaction to occur, we'll use platinum, which is an inert metal, as an electrode. So, two rods are placed. One is cathode, one is anode. We discussed we need to connect this one with the battery. So this contains, so this is a cathode, this is an anode, contains electrolytic solution of Ca. C means cation, A means anion. Usually in this case, sorry, the cation and anion are bonded with ionic bond or electrovalent bond, we can say. So what is the electrolytic solution? Ca, in which C plus and A minus will present. As this solution contains C plus A minus, cation and anion, C plus A minus, C plus A minus. This is electrolytic solution. So Two electrodes are dipped with made up of platinum metal. So let's see one by one. First, let's take at anode. Anode is always a positive terminal and cathode is a negative terminal. At anode, what happens? Usually oxidation occurs at anode. So anion A minus is going to form as A by the loss of one electron. If any species loses electrons, we'll say this one as oxidation. So this we can say as half oxidation reaction. Then let's see at cathode, which is a negative terminal. The released electron goes towards the cathode and reduction occurs. This C plus cation takes up this one electron and changes into C. So here gain of electrons is happening. So gain of electron is nothing but reduction. If we'll add these both the things, then what happens? One electron and one electron will get cancelled. A plus A minus, left side A minus, C plus gives rise to A plus C. This is about our reaction which is involving in the electrolytic cell. We are providing some electrical input. Or else what is C plus and A minus? Ca. Or else we can write this one as Ca gives rise to A minus plus C plus. This is Ca. So we can write Ca gives rise to A plus C. This is the reaction which is going to happen in case of electrolytic cell. If at all, for best example for this is any compound which is having ionic bond between them. So, or else we can say if any compound which splits into ions. Best example is NaCl. If NaCl undergoes electrolysis, Na plus plus half Cl2. And that too, this should be in molten state. Molten state. Why we are using molten state instead of aqueous state? What is molten state? What is aqueous state? If at all this compound is dissolved in water, then that should be called as aqueous solution of NaCl. What is molten state? If we heat the substance as it is without adding any water to it, after some times the solid itself converts into liquid. But in this case, heating is happening and without any addition of water. Why we are avoiding water here? Means we want only Na plus or Cl minus ions only to come and deposit either on cathode or an anode. We don't need any H plus or OH minus to come and deposit on cathode and anode. If at all we use aqueous solution, means if we use water along with NaCl, then what happens? H plus and OH minus will also come and act. To avoid that reaction to happen, we are using molten state. Means we are simply heating the NaCl solid so that it will convert into liquid after some times.